Welcome to the second half of this course, the trigonometry part. You've been going to algebra and trig for 7 or 8 weeks now, and we're finally starting the trig part. In the trig section, we're going to be working with triangles and angles quite a bit. And so I'm going to start with just this big triangle here and ask you if we're going to talk about the different sides of the triangle. So you see that we have a side here, another side here, and another side here. And it's going to be a little confusing to be like, I want the longest side, or I want the side that's the shortest, or the medium side, or it can just be, no, not that one, this one over here. It can just be a little confusing. So we kind of have come up with a naming system. And so the way we're going to do this is we're going to look at this in perspective to an angle. So every time we talk about the sides, we're going to relate them to an angle. So if I look at this triangle, you see we have one side here. How would you describe this side in relation to this angle over here? Hopefully you're seeing this as being opposite. This side is opposite of this angle. Okay, and so we are going to always refer to the opposite side of a given angle as being this one here. Now, if you'll notice, there's two other sides, this side and this side. And these sides are both next to the angle. This side is adjacent to this angle, and this side is adjacent to this angle. Adjacent just means next to. Now, since they're both adjacent, we solve this problem by talking about the hypotenuse. If you watched the Pythagorean theorem video, you remember the hypotenuse is the longest side, and it's the side opposite of this 90-degree angle. So this side here is the hypotenuse, and then we refer to this last side as the adjacent side. So technically the hypotenuse is adjacent to the angle as well, but just to keep things straight, we always refer to the hypotenuse as the hypotenuse, the opposite side here as the opposite side, and then the leftover one as the adjacent side. And as we talk about this, I want to pause a minute and look at a quick activity that let's see here, something went wrong. Oops. Try it here. There. All right. So I want you to imagine that we have three triangles, three right triangles. This is going to be a key point that they're right. And they all have, I should have asked you what you notice about these three triangles. Hopefully you noticed that they all have a 57-degree angle. Now, you might remember from your geometry class that if you have what are called similar triangles, these triangles are all similar, that we're going to have similar ratios. If you would take the opposite side of 57 degrees and divide it by the hypotenuse, you'll see something very interesting happen. So in each case, I have an opposite side here, and I have a hypotenuse. If I take that opposite side, 2.8, and divide it by the hypotenuse, 3.3, that's going to give me a decimal that's equal to 0.85. Now, I should mention, these were actual triangles that I had actually made and measured out. This is just a picture of those triangles. It's not drawn to scale. These are not drawn to scale. But if you were to create these triangles, these numbers would come out. This middle triangle here, I'm going to take that, and I'm going to take 5.5, the opposite side divided by the hypotenuse, 6.6, and that's going to give me a decimal of around 0.83. And if I do the same thing here, the opposite side divided by the hypotenuse, I'm going to get a decimal of 0.84. Now, this is really interesting to me, that no matter what triangle we started with, if we took the opposite side divided by the hypotenuse, we always got essentially the same answer. And the reason they're a little bit different is because of rounding and measurement error. So when I actually measured these triangles out, they came out to be 2.8, but they might have been slightly under or slightly over, which would change this ratio. This is a fundamental idea that is underlying all of trigonometry. And so today we're going to take a look at trig and look at these ideas. So let's get a few things out of the way. We're going to be talking about acute angles. Acute angles. This didn't work as slick as I thought it would. Acute angles are less than 90 degrees and more than 0 degrees. We're actually going to use some Greek letters to mark out our angles as variables. So when we're using numbers, we typically use X, Y, Z, maybe A, B, C. But when we look at angles, we're going to use Greek letters like alpha, beta, gamma, theta, and phi. I've already talked about this section of how we label the sides of our triangle. When we label the sides of our triangle, we always do it with respect to an angle. The hypotenuse is opposite the right angle. So you see that down here, the hypotenuse is opposite the right angle. Then there are two other sides. There's the side opposite of the angle, theta, and the side adjacent to the angle. And we've already talked through that, but the angle, the side opposite, the longest side, or the side opposite the right angle is the hypotenuse, and that leaves one side that's adjacent or left here to the angle. Now, I've mentioned it in this picture up here, but I'll mention it again here, that trig ratios are only used on right triangles. Okay, so if it's not a right triangle, these ratios aren't going to come through. And back to, I kind of missed the punchline here, but if you go back and you type into your calculator sine of 57 degrees, you'll find that the sine of 57 degrees is equal to about 0.84. What the calculator is doing is it's just storing the ratio. When you see the word sine, it's really just saying, give me a right triangle with a 57 degree angle. I don't care how big or how small it is. When I take the opposite side divided by the hypotenuse, the calculator is just storing that ratio of 0.84, 0.84, 0.84. Okay? And so when we work with trig functions, they're really just telling us different ratios. So these are definitions here. We're going to work with three main ones and then three others that are connected to the main ones. And so again, this is just a definition. You're going to want to memorize this. Sine is the opposite over the hypotenuse. So that's what I did up here. We took the opposite side divided by the hypotenuse to get that ratio. The calculator also stores that. If you have a right triangle with a 57 degree angle, it stores that ratio in the calculator for you. Cosine then is going to be really looking at a ratio, but instead of opposite over hypotenuse, it's taking the adjacent side over the hypotenuse. I don't have that here, but the same thing would happen if I took adjacent divided by hypotenuse. I would get a different ratio, and you could type in your calculator cosine of 57, and it would give you that ratio. It's about 0.54. And the last ratio that we get in most calculators is the tangent. Tangent is opposite over adjacent. Seemed like a good idea at the time. There we go. So that's just taking the opposite side divided by adjacent. All right, before I go into this next set of trig functions, I'm going to do a quick example. And I'm going to just zoom in here and have you think about it. If I said I've got 2/3, and I asked you, what's the reciprocal of 2/3? I'm guessing most of you would say 3/2, no problem. If I told you to take 1 divided by 2/3, I'm guessing some of you are having a little harder time with that. If I took 1 divided by 2/3, or 1 times the reciprocal, that's going to give you 3/2. Now check this out. Notice 1 divided by 2/3 is equal to 3/2. And so we see another way of looking at the reciprocal is by taking 1 divided by that number. Let's try it with another number. Let's take 1 divided by 5/4. You can go through this process and you'll see the answer is 4/5. And this is important because we're going to see over here that cosecant, secant, and cotangent are reciprocals. One last thing I want to talk about. If I take a decimal, let's take the number 0.75. If I take 1 divided by 0.75, it's going to give me its reciprocal. If you type it in your calculator, you're going to get 1.333 repeating. If you change that into a fraction, you're going to see that that is 4/3. Shouldn't be a surprise. I need to be a little careful here. So it's bothering me because 0.75 is not equal to 1 over 0.75. It's the reciprocal of that. 0.75, though, is 3/4. So this little 1 over trick works with decimals, it works with fractions, and over here we're going to write that with cosecant as well. And so we see that sine is the opposite over the hypotenuse. Cosecant is just the reciprocal of sine. And so we see here that cosecant is 1 over sine. Let me erase that for now. Or the hypotenuse over the opposite. Secant we'll find is the same idea. Secant is the reciprocal of cosine, tangent is the reciprocal of cotangent. And so we see here that if we have a triangle with a hypotenuse, an opposite, and an adjacent side based on our angle, if I want to find the secant of this angle, I need to take the hypotenuse divided by the adjacent side. I take this divided by this, and that will give me the secant, which is also the reciprocal of cosine, and so on. Cotangent, if I want to know the cotangent of this angle, I have to take the adjacent side of that angle to the opposite side from that angle. Divide them. That's going to be the same as the reciprocal of tangent, and you can see these are just flipped. All right. Let's take a quick break at this point. I'll do a quick review and then we'll end this video. So I've thrown a lot at you. Main ideas. Naming sides of a triangle is important. Understanding that it happens in relation to the angle. We've got an opposite, adjacent, and hypotenuse side. Second thing, if we have right triangles and an angle, I can then make ratios from different sides. In this example, I used opposite over hypotenuse, opposite over hypotenuse, opposite over hypotenuse. Each time, if we carefully measure and we find those ratios, they'll be the same. And so in this case, the calculator calls sine, actually all mathematicians call sine, is just sine is just a definition that means opposite over hypotenuse. And the calculator stores that value. For 57 degrees, it's about 0.84. I then gave you some different definitions here. We looked at the reciprocals of these functions and talked about naming them the reciprocal as 1 over that number. And that concludes this video. Thanks for